is equal to g of x all over h of x, where h of x is not equal to 0. So our numerator is g of x and our denominator is h of x. And the denominator of rational function, which is h of x, should not be equal to 0. Why? Because the function will be undefined. Because any number divided by 0 is undefined. So the denominator should not be equal to 0. And please remember that both the g of x and the h of x of our rational function should be polynomial. So let's have examples of rational functions. Okay, so number 1, we have the function of x is equal to 1 all over x. So this is a rational function because our numerator is a constant function, and constant function is an example of a polynomial function. Next, our denominator is x, which is a linear function. And linear function is also a polynomial function. So both our numerator and our denominator is polynomial. Therefore, f of x is a rational function. Second example, we have g of x is equal to x minus 2 over x squared minus 3x plus 21. So let's check if our numerator and our denominator are both polynomial functions. So first, x minus 2 is our numerator. So x minus 2 is a linear function. And again, linear function is a polynomial function. So this is correct. Next, denominator is, we have here quadratic function because the highest exponent here is 2. So linear function and quadratic function are both polynomial functions. So we can say that g of x is a rational function. Next, h of x is equal to 2x minus 4x squared over 5x. Again, our numerator, we have here the highest exponent is positive 2. So this is a quadratic function. Our denominator is a linear function. So both of them are polynomial functions. So h of x is an example of a rational function. So we have another 2 examples here, the function m of x and the function p of x. So let us identify if these 2 given functions are examples of rational function or not by using the definition of a rational function. Number 1, we have m of x is equal to x raised to 1/2 minus 5 over x squared minus 4. So first, let's have our numerator, x raised to 1/2 minus 5. Now we have here a fractional exponent 1/2, and if you transform that one into radical form, that would be the square root of x minus 5. Since we have radical sign, we can say that this is not a polynomial because it has radical sign again. So this is radical function. So since our numerator is not polynomial, we can conclude automatically that f of x is not a rational function. Next, number 2, p of x is equal to square root of x plus 5 over x minus 1. So our radicand here, okay, is x plus 5 over x minus 1. So this is rational function because our numerator x plus 5 and our denominator x minus 1 are both linear, and linear is polynomial. Though this one is a rational function by definition, however, they are just radicand of the radical function p of x. They are enclosed in a radical sign. So this is not a rational function, but rather a radical function. So again, not a rational function. Okay, so now let's discuss the domain and the intercepts of rational function. Before we have our example number 1, let us know first what is domain and what is x and y-intercept. So domain is the set of all x values that will make the function defined. The domain of a rational function is the set of all real numbers such that the denominator is not equal to 0. The x-intercept is the value of the x of the given function if y is equal to 0. And on the other hand, y-intercept is the value of y of the given function if x is equal to 0. Let's take example number 1. Find the domain in the x and y-intercepts of the function p of x is equal to x minus 5 over x plus 2. So first, let us find the domain of p of x. So we will have the domain. Now we said a while ago that the domain of a rational function is the set of all real numbers except those numbers or a number that will make the denominator 0. So our function is p of x is equal to x plus 2. Now our denominator here is x plus 2. So first we will find a number that will make this one 0. So x plus 2, what do you think is the number that will make x plus 2 0? Okay, so let's try. Let's have positive 2. So if we substitute positive 2 here in x, so that will be 2 plus 2, so 4. So that is not 0. So 2 is not the restriction in the domain. Now let's try negative 2. So negative 2, if we substitute it here in x, so negative 2 plus 2 is equal to 0. So negative 2 will make the denominator 0. Therefore, negative 2 is restricted in the domain of p of x. So we can write its domain as the set of all real numbers except negative 2. So we have the domain of p of x is the set of all real numbers except negative 2. Or in short, we can just have it as r except negative 2. So this symbol is a symbol for real numbers. So this is read as real numbers except negative 2. Next, we will solve for the x-intercept and the y-intercept of the function p of x. So again, the x-intercept of a function is the value of x when y is 0. And the y-intercept is the value of y when x is equal to 0. Let us solve for the x-intercept of the function p of x. So what we will do is we will just substitute 0 in y of the function. So in our function, our y here is p of x because p of x is also known as y. So our function is y is equal to x minus 5 all over x plus 2. So what I said, we will substitute 0 in our y for us to get our x-intercept. So y will become 0. So that will be x minus 5 over x plus 2. Now in this case, we will cross multiply for us to get the value of x. So this has a denominator of 1. So we will cross multiply 0 by x plus 2 and x minus 5 by 1. So x minus 5 times 1, we have x minus 5. And x plus 2 times 0, we have 0. So for us to get the value of x, we will transpose this 1 to the right side. So x is equal to 5. So our x-intercept is positive 5. That is, the value of x is 5 when y is equal to 0. Now let's go back to the process. Since in finding the x-intercept, we are substituting 0 to our y. So our left side of the equation is always equal to 0. And we always end up getting multiplying 0 by the denominator, in which the result is always equal to 0. Because 0 times any number is equal to 0. Now the shortcut is, we will just have to equate our numerator to 0. So our numerator is x minus 5. So x minus 5 equate to 0, so equals 0. Because the product of the denominator and the 0 here is 0, so that has no value at all. So we will just focus on our numerator. So x minus 5 is equal to 0. So get the value of x, transpose negative 5. So x is equal to positive 5. So we have the same answer. X-intercept is positive 5. So this is just a shortcut in finding the x-intercept of the given function. Now let's have the y-intercept. So y-intercept again is the value of y when x is equal to 0. So we will make the x of p of x 0. So what we will solve here is the p of 0. So x minus 5, x will become 0. 0 minus 5 over x plus 2, x will become 0, therefore 0 plus 2. Then simplify, 0 minus 5 is equal to negative 5. 0 plus 2 is equal to positive 2. So our answer is negative 5 halves. So the value of y is negative 5 halves when x is equal to 0. So our y-intercept is negative 5 halves. Okay, example number 2, we have f of x is equal to x squared plus 7x plus 10 all over x plus 2. So first, we will find the domain of f of x. So our function is f of x is equal to x squared 7x plus 10 all over x plus 2. Since we are looking for the domain, our focus is the restriction in the denominator. So we will just focus on the denominator of f of x. So for us to get the restriction in the denominator, we will equate x plus 2 to 0. So x plus 2 is equal to 0. To get the x, we will transpose this one. This will become negative 2. So the restriction in the denominator is negative 2. Because negative 2 plus 2 is equal to 0. So negative 2 will make our denominator 0. So this is restricted in the domain. So our domain is the set of all real numbers except negative 2. Next, our x and y-intercept. So x-intercept, that is when y is equal to 0. So the shortcut is, we will just equate our numerator to 0. In finding the restriction in our domain, we will equate the denominator to 0. But in finding the x-intercept, we will use the numerator and we will equate that one to 0. Since our numerator is a quadratic function, because the highest exponent is 2, that is in x squared plus 7x plus 10, therefore, we will factor it out first to see if there are cancelable terms. So we will factor out x squared plus 7x plus 10. So f of x is equal to x squared plus 7x plus 10 over x plus 2. So we will factor it out. The factors of x squared plus 7x plus 10 is x plus 5 and x plus 2. We already discussed factors in our previous topic, so you just have to review that one. The factors are x plus 5 and x plus 2. So we have similar terms in our numerator and in our denominator, which is x plus 2. So we will cancel them. So the remaining terms or expression is x plus 5. So only x plus 5 will be equated to 0 in order for us to get the x-intercept. So x plus 5 is equal to 0. To get the x, we will transpose positive 5. Therefore, x is equal to negative 5. So our x-intercept is negative 5. That is the value when y is equal to 0. Now, if we do not factor x squared plus 7x plus 10, we end up equating x plus 5 and x plus 2 to 0. So we end up getting our x-intercepts are negative 5 and negative 2, where in fact negative 2 is restricted in the domain. So negative 2 can't be the x-intercept of f of x because this is the restriction in the domain of f of x. So first, we will check if there are cancelable terms in our function so that we can cancel them out. Next example, we have b of x is equal to 3 all over x squared minus 4. So first, let us get the domain. B of x is equal to 3 all over x squared minus 4. So in finding the domain, we will just focus on the denominator because we are looking for the restriction in the domain of b of x. So since our denominator is a quadratic function, we can expect that we have two restrictions in the domain. So we have two values of x. So we will equate x squared minus 4 to 0. To get the 2x, we will factor it out. Since this is sum and difference, the factors are positive 2 and negative 2. So we have quantity of x plus 2 times the quantity of x minus 2 is equal to 0. So we will equate 1 by 1. So x plus 2 is equal to 0. X of 1 is negative 2. The other one, x minus 2 is equal to 0. So x of 2 is positive 2. So we have two restrictions in the domain of b of x, that is negative 2 and positive 2. So our domain is D is the set of real numbers except positive and negative. Next, let's find the x-intercept of b of x. X-intercept is the value of x and y is 0. Now, in finding the x-intercept, we will equate the numerator to 0, that is the shortcut. So since our numerator is a whole number, positive 3, we have no variable x. So in this case, we have no x-intercept. Again, if our numerator is a whole number, we have no x-intercept. We'll proceed to the y-intercept. So y-intercept, we will substitute 0 to the x. So we will solve for b of 0. So 3 all over 0 squared minus 4. So 3, 0 squared is 0, minus 4 is negative 4. So 3 divided by negative 4 is negative 3 all over 4. So our y-intercept is negative 3/4. So this is the value of y when x is 0. So our y-intercept is negative 3/4 and we have no x-intercept.